In this lecture, we will discuss the Frobenius method of series solution, and we will discuss about two particular cases. The first case is that when the roots of the initial equation are equal, and the content of the lecture is from the textbook of H.K. Das and Verma. The book is Higher Engineering Mathematics. In my earlier lecture, I have already discussed about a particular case, and in this lecture I am going to discuss about two cases. So the first case is that when the roots of the initial equation are equal, and in the previous lectures I have already discussed that what do you mean by initial equation. So I request the listeners to listen the earlier lectures at first to understand this lecture clearly. So this is a particular differential equation, and we are going to solve this. So at first what we have to do, that is we have to express such type of equation in the standard format, so that we can calculate the type of the point x is equal to 0. So after expressing this equation in standard form, and if we calculate the value of the x into px and x square into qx, and we can find that they are not infinite at the value x is equal to 0. So x is equal to 0 is a regular singular point. So every time we are going to solve a series solution, the first step is to check that whether x is equal to 0 is a regular singular point or not. So after checking that x is equal to 0 is a regular singular point, we will assume the solution of the equation in the form that is y is equal to k is equal to 0 to infinity a k x to the power m plus k. This is the we are assuming that this is the solution of that particular equation, and then we will determine dy by dx and d square y by dx square from the value of y is equal to sum of a k x to the power m plus k, where k is equal to 0 to k is equal to infinite. So these are the values of dy by dx and d square y by dx square. Next what we will do, we will substitute these values in the given equation. There are y prime and y double prime. So we will substitute these values in the given equation, and after the substitution we will have this equation. So after having this equation, what we have to do, we have to simplify this equation a little bit. So these are the simplification process. So after the simplification process, what we will obtain, we will obtain this equation number 2, that is sum factor into x to the power m plus k minus sum factor into x to the power m plus k minus 1 is equal to 0. The previous process is very simple, just you have to multiply, because you see that with this summation you have to multiply x into x minus 1. So we have to multiply this factor with this factor. Similarly, you have to again multiply 3x minus 1 with this factor, and after multiplication, and you have to rearrange the equation so that you can have a simplified form described in equation 2. So here the power of x is m plus k, and some summation factor is multiplied with x to the power m plus k, and here the power of x is m plus k minus 1, and some summation factor is multiplied with x to the power m plus k minus 1. Now you see, you look at the term, that is this is x to the power m plus k minus 1. Now the coefficient of lowest degree term x to the power m minus 1 in this equation can be obtained if we put k is equal to 0 and the second summation only, because you see that if we put k is equal to 0, then the power of x will be m minus 1, but this is only valid for the second term, because for the first term we put k is equal to 0, and this will become x to the power m. So, to obtain the coefficient of lowest degree term x to the power m minus 1, we have to put k is equal to 0 in the second summation. And if we put the k is equal to 0 in the second summation, and if we make the coefficient 0, then we will obtain a0 into m plus 0 whole square is equal to 0, or m is equal to 0 comma 0, as a0 not equal to 0. And the coefficient of the next lowest degree term x to the power m in equation 2 can be obtained if we put k is equal to 0 in the first summation, because you see, if we put k is equal to 0 in the first summation, then power of the x will be m, and we have to put k is equal to 1 in the second summation. In that case only, and the power of the x will be m. So we have to put k is equal to 1 in the second summation and then we will obtain this equation, that is putting k is equal to 0 in the first summation and k is equal to 0 in the second summation. We will obtain the coefficient for the lowest degree term x to the power m, and we are equating this coefficient to 0. And from this equation we can have a relation between a1 and a0. So we can see easily that is a1 is equal to a0, because m is equal to 0, as we have obtained earlier. Now you again look at the equation 2, and after equating the coefficient of x to the power m plus k to 0, we can obtain a recurrence relation. We have already discussed that is what do we mean by recurrence relation. Actually, recurrence relation is the different relation between the a terms. So to obtain a such type of recurrence relation, what we are doing, we are equating the coefficient of x to the power m plus k to 0. But here we have to keep in mind a point, that is, it is not necessary to equate the coefficient of x to the power m plus k is equal to 0. I will show you several examples, that is, depending on the structure of this equation, you have to put the coefficient of x to the power something to 0, and this will depend on the power of the x in this equation. But in this particular equation, what we are doing, we are equating the coefficient of x to the power m plus k to 0 to obtain the recurrence relation. Now you see that here the power of the x is m plus k minus 1. So to convert m plus k minus 1 to m plus k, what we have to do, you have to write k is equal to k plus 1 in the second summation. And if you write k is equal to k plus 1 in the second summation, then you will have the power x to the power m plus k. So then after writing k is equal to k plus 1 in the second summation, and after equating it to 0, that is following this step, we can obtain a relation between different a terms. For example, from this equation, we are having a k plus 1 is equal to a k. For this particular problem, a k plus 1 is equal to a k. If we equate the coefficient of x to the power m plus k to 0, I am again repeating. You see that in the first term there is already x to the power m plus k, but in the second term there is x to the power m plus k minus 1. So to convert it to the x to the power m plus k, we have to write k is equal to k plus 1 here, that is a k plus 1 m plus k plus 1 square. This one, a k plus 1 m plus k plus 1 square is equal to 0. So ultimately we are obtaining a k plus 1 is equal to a k. That means if we put k is equal to 0, that means a1 will be a0. Then if we put k is equal to 1, then a2 will be a1. So a2 is equal to a1 is equal to a0. So every term can be expressed in terms of a0. So ultimately the solution will be, that is y is equal to, you see the first equation, y is equal to sum of a k x to the power m plus k for k equal to 0 to infinity. We have to put the different values of a in this equation, and if we put different values of a in this equation, so we can write the general solution, y is equal to x to the power m, and inside the bracket a0 plus a1x plus a2x square, but every a term can be expressed in terms of a0. That is why we have taken a0 common. So a0 x to the power m, and inside the bracket 1 plus x square plus x cube, in this way. So for m is equal to 0, we can write, that is first solution y1, the first solution y1 will be putting m is equal to 0 here, then x to the power m will be just 1. So y1 is equal to a0 plus 1 plus x square plus x cube. This is the first solution of the equation. But there will be another solution. To calculate the another solution, what we have to do, if this is the value of the x, so we will differentiate y with respect to m and calculate del y by del m. So this is the value of del y by del m if y is this. This is the value of the del y by del m. You see there is x to the power m. So if you differentiate it, then you will obtain x to the power m log x. This is del y by del m. So the second solution will be if we put m is equal to 0 here. So del y by del m is equal to 0. This is the second solution. So second solution y2 is equal to, if we put m is equal to 0 here, so y2 will be a0 log x and into 1 plus x square plus x cube, so on. So this is the second solution and this is the first solution. So the general solution will be y is equal to constant a into y1 plus constant b into y2, where y1 is equal to this and y2 is equal to this. So this is the general solution for the given problem. Now we will discuss another problem for more clear understanding. Suppose this is the given equation and we have to solve it. So at first we are writing this equation. Then again what we have to do, we have to express this equation in standard format, and you have to check that whether x is equal to 0 is a regular singular or not. But after the checking, we can see that x is equal to 0 is a regular singular point. So we have to assume the solution of the equation y is equal to this one, that is as we are assuming in every case a k x to the power m plus k. So you have to calculate dy by dx, then d square y by dx square, then substitute all these values in the given equation. So we have put all these values in the given equation. Then what we have to do, you have to rearrange, you have to multiply x with this factor, then we have to multiply x square with this factor, then we have to rearrange and simplify. So after simplification, equation 2 can be obtained. So equation 2 is ak into m plus k whole square x to the power m plus k minus 1 plus sum ak x to the power m plus k plus 2 is equal to 0. So you again see the powers of x. Here this is m plus k minus 1 and here this is m plus k plus 2. Now the first step is that you have to calculate the coefficient of the lowest power of x. So here if we put k is equal to 0, so lowest power of x will be x to the power m minus 1, because you see that here the power of the x is m plus k minus 1, and always you have to calculate the coefficient of the lowest degree term. So here this will be x to the power m minus 1, and it can be obtained if we put k is equal to 0 in the first sum only. So in the first sum only we will put k is equal to 0, and if we put k is equal to 0 here, then the initial equation will be a0 m square is equal to 0. So m is equal to 0 comma 0. Again the same case has been obtained. Then what you have to do, you have to calculate the next lowest coefficient of the next lowest power of x. So if this is x to the power m minus 1, so next we are going to calculate the coefficient of x to the power m. So how we can calculate the coefficient of x to the power m? In that case what we have to do, you have to put k is equal to 1 here, then the power of the x will be x to the power m in the first summation only, and we have to equate to 0. And if we equate to 0, then we can see that a1 is equal to 0, because m is equal to 0, so a1 is equal to 0. Now what we can do again, that is we can again calculate the coefficient of next lowest power of x, that is x to the power m plus 1. So if we want to obtain the coefficient of x to the power m plus 1, then you have to put k is equal to 2 here. So then it will be m plus 1. So after putting the value k is equal to 2 in the first summation only, you are obtaining that is a2 is equal to 0. Then what we will do, we will obtain a recurrence relation, that is a general relation between the a's. So in this case what we have to do, that is we will equate the coefficient of x to the power m plus k plus 2 to 0. Actually I have already told that is how the recurrence relation can be obtained. Actually this will depend on the type of the structure of this equation. So in this particular equation, what we can do, we can calculate the coefficient of x to the power m plus k plus 2, because you see here the power is already m plus k plus 2, but here we can convert the power into m plus k plus 2 if we put k is equal to k plus 3 here, because if we put k is equal to k plus 3, then the power of the x will be m plus k plus 2. So equating the coefficient of x to the power m plus k plus 2 to 0, from this equation we can write this one, that is ak plus 3 m plus k plus 3 whole square plus ak is equal to 0. So ak plus 3 is equal to minus of ak by m plus k plus 3 whole square. Now we can obtain the relation between different a values. For example, suppose if we put k is equal to 3, then we can obtain, that is a3 is equal to some factor into a0, and if we put k is equal to 1, then you can obtain, that is a4 is equal to some factor into a1, but we have already calculated that a1 is equal to 0, so a4 will be 0, and similarly a7 will be 0, a10 will be 0. If we put k is equal to 2, then you can calculate a5, a8 and a11. In this way you can calculate different values of a by putting different values of k. So after you have estimated a sufficient number of a values, then what we can do, that is we have already written the general solution of the equation in this particular format, that is y is equal to sum of a k x to the power m plus k, and we have already evaluated different values of a for different k values. So the general solution will be, after looking at these values of a, so the solution will be like this, that is y is equal to x to the power m a0 and this factor. So equation 3 gives the general solution, that is y is equal to this one. But we have already seen, that is there are two values of m, that is m is equal to 0 and 0. So first solution can be obtained if we just put m is equal to 0 here. So in that case x to the power m will be just 1. So y1 will be a0 into this one, that is you have to again put m is equal to 0 here, and we can get a simplified equation 4. This is the first solution. And to obtain the second solution, what we have to do, you have to at first calculate del y by del m. This is x to the power m, and there are different values of m also here in the denominators. So you have to differentiate it very carefully. So this is y, so del y by del m is equal to this one. This is the value of the del y by del m. So in this particular value of del y by del m, you have to put m is equal to 0 to obtain the second solution. So in this right hand side, you have to put m is equal to 0, then you will get a simplified expression, that is equation 6. So equation 6 has been obtained by putting m is equal to 0 in equation 5. So del y by del m at the point m is equal to 0 will give you the second solution. This is y2 is the second solution, and y1 you have already obtained earlier. So the general solution will be y is equal to c1 y1 plus c2 y2. So this is what about the case when the roots of the initial equation will be equal, for example 0 and 0. So you can go through some more examples from the textbook of Das and Verma, but now we will discuss another case, that is when m1 and m2, that is the roots of the initial equations are distinct and they differ by an integer. So in that case the general solution will be y is equal to c1 y m1, that is for a particular value of m1 you have to calculate the solution. So c1 y at the point m1 plus c2 del y by del m at the point m2. This is the structure of the general solution. So let us go through an example. So this is the differential equation and we have to solve it. So at first just like earlier problems, you have to check that whether x is equal to 0 is a regular singular and not or not. So after checking the x is equal to 0 point, you have to assume the standard format, that is you have to assume y is equal to this one. Then you have to calculate dy by dx and d square by dx square. Then you have to substitute all these values in the given equation, and you have to simplify. So after simplifying, you are obtaining equation 2. Then you have to calculate the lowest degree, that is coefficient of lowest degree term, coefficient of lowest degree term x to the power m. It will depend on the problems. In some cases you will see that the lowest degree term will be x to the power m minus 1, but in some cases it will be x to the power m. For example, here the coefficient of the lowest degree term x to the power m, we will calculate the coefficient of the lowest degree term x to the power m. This can be obtained if we put k is equal to 0 in the first summation only, and you have to equate it to 0. So you have to put k is equal to 0 in the first summation only and equate to 0. Then you will see that m is equal to 2 comma minus 2. So you are obtaining two distinct roots. They are different, and they don't and they differ by an integer. They differ by an integer. So this is the structure of the solution. So what you have to do, after calculating the initial equation, you have to calculate the coefficient of the next lowest term x to the power m plus 1. So how it can be obtained? You have to put k is equal to 1 in the first summation only and equate to 0. Then you will see that a1 is equal to 0. Then you can calculate the that is general recurrence relation. So for that purpose, what you can do, here you see that the power of the x is x to the power m plus k plus 2. So what we can do, that is we can calculate the coefficient of x to the power m plus k plus 2 and equate to 0. So this is m plus k. In the first term, the power of x is m plus k. So what we can do, we can write in place of k plus 2. If we write in place of k plus 2, then this will be also m plus k plus 2. Here is also m plus k plus 2. So in the first summation, we have to write k plus 2 in place of k. So then we can have this equation, that is we are writing k plus 2 in place of k. So this will be a k plus 2. This one is m plus k plus 2. So we are writing k plus 2 in place of k. So m plus k plus 4. Then m plus k minus 2, but we are writing k plus 2 in place of k. So this will be m plus k plus ak, that is from the second term. This is 0. So this is the general recurrence relation, and from the general relation we can see that a1 is equal to a3 is equal to a5 is equal to 0, and we can also calculate a2, a4, a6. So after calculating several values of a, we can write the general solution y is equal to this one, that is as y is equal to this one. So from after calculating different values of a, we can write the general solution y is equal to this one, that is equation 3 is the general solution. So at first what we have to do, as we have obtained two values of m, so first value is m is equal to 2. So just put m is equal to 2 in equation 3. Then you will obtain the first solution. So y1 will be a0 x square, and you have to put 2 in place of m in the third bracket. So you will obtain y1 is equal to this one. So equation 4 will be the first solution. And to obtain the second solution, you have to follow a particular step. But before that, you look that if we put m is equal to minus 2, then some term goes to infinite, because here in the denominator there is m plus 2. Here is also in the denominator m plus 2. So if we put m is equal to minus 2, so what can happen, that coefficient of x to the power 4 and x to the power 6 becomes infinite. So we have to apply particular trick for this particular problem, and to overcome this difficulty, we are assuming, that is we put a0 is equal to b0 into m plus 2 in this equation. That means there is a term a0. A0 is basically a constant, but this constant we are writing in this way, that is b0 into m plus 2. If we multiply m plus 2, then what will happen, this m plus 2 terms in the denominator will be cancelled. That is why we are writing this particular constant in this manner, that is a0 is equal to b0 into m plus 2 to overcome the difficulties. So then equation 5 will be the general solution. Here we have applied a particular trick, and that trick is we are writing the constant a0 in this manner. Now what we will do, we will differentiate equation 5 with respect to m. So after differentiation we are obtaining this equation, and in this equation what we have to do, you have to replace m by minus 2 to obtain the second solution. So we are going to calculate del y by del m for m is equal to minus 2. So you have to write m is equal to minus 2 in the right hand side. So then you will obtain this equation. So del y by del m for m is equal to minus 2 is the second solution y2, and first solution y1 we have already obtained. So general solution will be y is equal to c1 y1 plus c2 y2. Let us go through another example for this particular case. Suppose this is the equation. So after checking the singular point, we are assuming the general solution in this manner, just like the previous examples, and we have to substitute this value in the given equation, then simplify it. So after the simplification, this is the simplified version, that is here the power of x is m plus k, and here this is m plus k minus 1. Now what we have to do, we have to calculate the coefficient of the lowest power of x, that means x to the power m minus 1, because you see the power of x is m plus k minus 1. So we have to calculate the coefficient of the lowest degree term x to the power m minus 1, and for that purpose we have to put k is equal to 0 only in the second term and equate it to the 0. So after equating to 0, we are obtaining m is equal to 0 comma 2. So they are two distinct roots and they differ by integer. So next what we will do, we can calculate the generalized equation, that is the recurrence relation. So the recurrence relation can be found if the coefficient of x to the power m plus k minus 1 is obtained. So you see that this will depend on the type of problems, and the recurrence relation can be obtained in different ways. So it depends on you, and depends on the type of the equation, and depends on the convenience. For example, here we are doing, we are finding the coefficient of x to the power m plus k minus 1. So x to the power m plus k minus 1 is obtained if we put k is equal to k minus 1 in the first summation and k is equal to k in the second summation. So in this way you are obtaining a general equation like this, that is ak is equal to m plus k by m plus k minus 2 ak minus 1. So you can obtain the value a1, then a2, then a3 in this manner. So the general solution y is equal to sum of ak into x to the power m plus k will be like this, that is you have to put different values of a, and ultimately what you can obtain, you can obtain a general solution like this. This is the structure of the general solution. Equation 4 is the general solution. Now we have obtained 2 points, that is one for 0 and another for 2. So in the first case, for example, suppose for m is equal to 2, if we put m is equal to 2, so the equation will be like this. In equation 4 you are putting m is equal to 2, so y is equal to a0 x square, in the third bracket 1 plus 3x plus 6 square 6x square. So this is suppose a0 into u. Now for m is equal to 0, suppose in the above series, if we put m is equal to 0, then the coefficient becomes infinite, because you see in the denominator there is m. So as the coefficient becomes infinite, so you have to overcome this difficulty like the previous problem. To remove this difficulty, you have to modify equation 4 by putting a0 is equal to m into b. Actually what you have to do, you have to modify the denominators in such a way so that the term does not go to infinite. So we are putting a0 is equal to m into b, So in that case m will be cancelled out. So after putting a0 is equal to m into b, this is the modified version. So equation 6 is the modified version of the general solution. Now what you have to do, you have to differentiate equation 6 with respect to m. So after differentiating, this is the structure of the general solution del y by del m, and in this del y by del m you can put m is equal to 0 to get the second solution. So putting m is equal to 0, we are obtaining the second solution. So the general solution will be y is equal to a0 u plus b into v. So this is the general solution. So actually you have to apply some tricks for this particular case. Thank you all for listening.